Hello and welcome to another one of these ADD videos. Today we're going to be looking at part 2 of the Extrema videos, the relative extrema. What is a relative extrema? So relative extrema doesn't have to do with your crazy cousin that goes mountain biking off of actual mountains or jumps off of cliffs or out of airplanes. It has to do with the slopes. Is it increasing and then decreasing as a max would be, or decreasing then increasing as a min would be? In relative extrema, we are no longer looking at a portion of the function, we're looking at the entire function, and we're looking at the slopes of the tangent lines. And we get the slopes of the tangent lines by doing the first derivative. And you find the critical points, and you plug in into the first derivative, not the critical points themselves, but test points on either side. Okay, so when we plug in a test point on either side of this critical point, okay, obtained by setting the first derivative equal to 0. So you plug in a test point to the left and the right of the critical point, whatever the critical point would be. Here, all these critical numbers are going to be the ones where the first derivative equals to 0. So you pick a point to the left and the right of each critical point. And we need to test on either side of these critical numbers. Okay, so you plug in a point to the left of this critical number, to the right of this one, left, right of each one of these. And you will analyze what's going on with the slope. Does it go from plus to minus, minus to plus? So minus to plus is a min, plus to minus is a max. Some people prefer a tabular method. I prefer a number line. Do whatever suits you. I'll show you both methods in the example videos. If we have an increasing slope, then a decreasing slope, wherever that may be on either side of a critical point, left to right, then increasing, decreasing indicates at the critical point in between that we have a max. Make sure that we're not dealing with asymptotes because they can't be maxes or minimums if they're asymptotes. Okay, remember it's relative max and min. Remember we have to do the x value and the y value to label it. All right. Sometimes if you're run out of time, you can just put f of whatever your x value is because you don't want to solve for y. But you let the grader know that you know that that's how you find the critical point. Okay. Anytime we have decreasing then increasing, wherever the x value may be, providing it's not an asymptote, then we have to the left and then the right a relative minimum. All right. So if you don't have to determine whether it's increasing or decreasing, then you can just use the second derivative test. And in the second derivative test, what you do is you plug in the critical number, not a test point, into the second derivative. If it's greater than 0, it's a relative min. If it's less than 0, it's a relative max. The only problem is if it's equal to 0, it's inconclusive, and you have to do the first derivative test. This is a great way to check your work. Okay? So this whole time I've been talking about these things called critical points. What are critical points? Well, critical points are your possible maxes or mins. Okay, so the first way we did it was we said set the first derivative equal to 0. That's anywhere we have a horizontal tangent line, so that's indicated by a derivative equaling to 0. Well, how do we find all these critical points? Well, there's one of three major ways. We discussed the first derivative equal to 0. The second is if the function's continuous but not differentiable, meaning it's okay in the original function, but when I take the derivative, it's undefined in the derivative. Defined, undefined. Okay, and then the last critical number is an asymptote. The special thing about the asymptote is it won't be a max or a min, even though the slope can change on either side. Okay, so this is the premise that you're going to be doing all these problems on. So check out the example videos. I'm going to do some beginner, intermediate, and advanced as always. Maybe throw in some trig for you univariate calculus people. But the key is to practice as many of these as you can. All right? I hope I've cleared up any confusions that you might have, enough for you to overcome your fears and just try a few problems. Thank you, and have a nice day.